The Taylor series is a very important topic in calculus. So before we get there, let's just talk in general about sequences and series. So let's start with a sequence. A sequence is just an ordered list of numbers. So I'm going to write that as a sub 1, a sub 2, a sub 3, etc. So we have our A's are representing the numbers and the subscript representing the different numbers. And then we'll have the natural numbers as the subscripts, 1, 2, 3, etc. So let's look at an example. My favorite sequence is the Fibonacci sequence, which gives us the Fibonacci numbers. The Fibonacci numbers satisfy what's called a recursion relationship, which we write as f sub n plus 2. The n plus 2 Fibonacci number is equal to the n plus 1 Fibonacci number plus the nth Fibonacci number. So it tells us the next number in the Fibonacci sequence is the sum of the previous two numbers. We have to start somewhere. So we usually start with f sub 1 equals f sub 2 equal to 1. And when we do that, then we have the first two Fibonacci numbers, 1, 1. The next one then is the sum of these two. So it will be 2. And then the next one is 1 plus 2 is 3. And then 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13, 8 plus 13 is 21, etc. So we end up with our Fibonacci sequence. Also, I should define a series. So what does a series look like? Well, a series then is a sum of a sequence. So we can write that as the sum from k equals 1 to n of a sub k. So the summation symbol means that this is a sub 1 plus a sub 2, etc., up to the last one, which would be a sub n. In this course, we'll be mainly interested in infinite series. So the infinite series is the limit that n goes to infinity. Three things can happen in this limit. The first one is that the series can converge, so then it converges to some number. That's probably the most important case to consider. The other one is that it could diverge, which means that it ends up going to infinity. It keeps growing and growing as you add more a's to it. That also happens, and it's also quite important. The third case, which we won't really see in this course, is that it could never settle down, so never settle. But we won't deal with series that look like that. Okay, it's actually possible to convert a series to a sequence. So series to sequence, that's by calculating what's called partial sums. So what would be a partial sum here? Well, A1 would be the first term in the sequence, and then the second term in the sequence would be A1 plus A2, and the third term would be A1 plus A2 plus A3, etc. So we've converted then the partial sums of this series, the first number, the sum of the first two, the sum of the first three, into then a sequence. So now let's, instead of looking at the Fibonacci sequence, we can look at the Fibonacci partial sums. Fibonacci partial sums. So the idea then being, can we calculate the value of the Fibonacci partial sums? So let's have a look at that. How can we do that? We can start by writing this recursion relation in a certain way. So we want to find the sum of the first n Fibonacci numbers. So on the left-hand side, we can write f sub n. And then we can solve this equation for f sub n would be f sub n plus 2 minus f sub n plus 1. Okay, so f sub n equals f sub n plus 2 minus f sub n plus 1. We want to find the sum of the first n Fibonacci numbers. So below here, we can write f sub n minus 1. And then we shift all the indices down by 1. So this would be f sub n plus 1 minus f sub n. The next term would be f sub n minus 2. And that would be shift down by 1, f sub n minus f sub n minus 1. And then we keep going all the way down to the last one, which would be f sub 1, right? So this is 2 above that. So this would be f sub 3 minus, and this is 1 above that. This would be f sub 2. And the idea then is that we're going to sum all of these numbers on the left and sum all of these numbers on the right. But if you look at the right, a miracle happens here. So this minus f sub n plus 1 exactly cancels f sub n plus 1 below it. So these two cancel. The minus fn exactly cancels fn. So this cancels. And so on all the way down. So this cancels something there, and then this f3 gets canceled. So if we sum the left-hand side, then we would get the sum from k equals 1 up to n. And then these are the f's. So f sub k is equal to the sum of the right-hand side. Everything is canceling except the first number here, f sub n plus 2. Minus f sub 2. But f sub 2 is one of our initial values equal to 1. So f sub n plus 2 minus 1. So you can try this out. These are the partial sums of the Fibonacci numbers. You can try them out for some of these numbers here. So let me summarize. I've defined sequences and series. And our main interest in this course will be the infinite series, and when this series converges, when does it diverge? I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.